So I'm going to use the IPCC way of depicting the future risks associated with levels of global warming, and I keep adding modern human as a tagline in each of these podcasts because I want us to remember that we're talking about climate and evolution. So usually climate change in this 21st century is discussed without worrying about the evolutionary context, but in this course we want to kind of keep that in the back of our mind. Okay, so how does IPCC latest report depict these risks? We read a bunch of things, examples from the tables. So here let's look at global and regional risks for increasing levels of global warming. Global surface temperature change increase relative to the period 1850 to 1900, which is used as a baseline. So you can see the historic warming here with the gray band showing the range of model simulations that are used for the IPCC assessment, and then they go into the future with the various shared socioeconomic pathways that we talked about in terms of that phase diagram. We looked at increasing difficulties with mitigation, adaptation, regional rivalries, sustainability, and so on. So this divides it into these different categories of reasons for concern, RFCs, and thinks of impacts and risk assessments assuming low to no adaptation. So adaptation, as we said, is changing our behavior. So in the context of our climate and evolution paradigm, we respond to environmental changes and not think we are smart enough to work with technology to overcome any perturbation. So we will assume that there are some things that are unmanageable, unavoidable, so we do adaptations for managing the unavoidables as opposed to mitigation, where we want to try and avoid the unmanageable, right? So words, but the convention here is, of course, risk is very high in these reddish colors, high in the lighter red color, moderate in the yellow color, and risk is undetectable in the blank regions, white regions, and there is a transition range, and assigned confidence levels to the transition go from low to very high. So when these syntheses are done for the future, there is a evaluation of our confidence in claiming these risks. There are uncertainties associated with these, but the way to think about it is there is a risk, there is a challenge. Are you going to say you are not going to worry about the risk, potential risk, or are you going to respond to it with low or no adaptation? Right? So historical average temperature increase between 2011 and 2021 was 1.09 degrees centigrade with a range of 0.95 to 1.2 degrees C. This is important because the warming has accelerated if you compare to the periods before. So if you go to something like 1980 to 2011 versus 2011 to 2020, there is a significant increase in the warming rate. So this is something that has to be kept in mind as well. So reasons for concern 1, 2, 3, 4, 5 here. Take unique and threatened systems, could be tundra, corals, Great Barrier Reef kind of systems. Extreme weather events, distribution of impacts in terms of how they events translate into global consequences, let's say. Global aggregate impacts, so how is something like a increased range of dengue going to affect the entire population? I'm just using as examples so you can follow up on the IPCC report, and I have under my climate change course multiple podcasts going through the IPCC executive summaries from multiple working groups. They have working groups on physical science behind it, and synthesis and mitigation and adaptation, and impacts and vulnerability, I think, or something like this you can look up. Okay, large scale singular events. We didn't discuss things like tipping points, threshold, switching points, and so on. switches, thresholds, and tipping points, but there is a lot of literature on that. I find them to be a little bit heuristic arguments in terms of putting confidence levels on them. But things like the Arctic sea ice, summer sea ice, Amazonia, Greenland ice sheets, Arctic sea ice, etc. have to be watched out for. Okay, so you can see that depending on the range of warming here, the risks increase for all of them, but the unique and threatened systems hit high risks very early on in the game, down below 2 degrees C, and then if we go beyond 2 degrees C, already it's pretty well agreed upon that everything is going to face high risks, and we can say that with some level of confidence here. And extreme weather events, confidence level drops here down to lower end by 2 degrees C warming, but obviously already we are seeing increased extreme events in terms of rainfall, floods, flash droughts, what else? So heat waves and so on and so forth. Distribution of impacts again remains with low confidence, reasonably high risk up to 3 degrees C warming, extends also for global aggregate impacts and large scale singular events, and you can see these are these have much lower confidence as well in assigning the transitions. Okay, so this gives you a sense that we are working hard to understand what are the potential outcomes, risks associated with our fossil fuel emissions and expected warmings. So you can look at impacts and risks to terrestrial and freshwater ecosystems, again in the warming ranges. So biodiversity loss, ecosystem structure changes, tree mortalities, wildfire increases, and carbon loss from the terrestrial ecosystems and freshwater ecosystems. Lot of wildfire increase and tree mortality studies are already done. When it comes to things like wildfire increase, you always have to look at whether there are more number of fires or more intense fires or larger areas burned and so on. So those kind of studies have been done, and there is evidence that intensity and areas burned are increasing with attribution to global warming. Impacts and risks to ocean ecosystems, which include warm water corals, kelp forests, seagrass meadows, epipelagic, so upper ocean, upper water ecosystems, rocky shores, where you have unique ecosystems of shellfish, crabs, lobsters, and so on, and salt marshes, which are also good. Kelps and salt marshes and so on are very good sinks of carbon. So you can see here confidence levels tend to be lower in some of them. Look at climate sensitive health outcomes under 3 adaptation scenarios. So now we are moving away from no adaptation. Here assuming low to no adaptation, here we are considering multiple adaptation scenarios, and those scenario narratives are often referred to as storylines, correspond to limited adaptation, failure to proactively adapt, low investment in health systems, incomplete adaptation, so incomplete planning, moderate investments in health systems, proactive adaptation, proactive adaptive management, higher investment in health systems. Okay, again, warming levels, looking at heat-related morbidity and mortality, ozone-related mortality, malaria, dengue, and other diseases carried by species of Aedes aegypti mosquitoes, which are carriers of some of these diseases, and their range and population is expected to increase as warm temperatures also hold more moisture, vegetation changes, urban population, standing waters, whatever the ecosystems and habitats that the mosquitoes prefer. So we're looking at limited adaptation. Incomplete adaptation reduces the risk here. Proactive adaptation, you can see, extends the region of low risk to 2 degrees C. Similarly, ozone-related mortality, limited adaptation has high risks. Incomplete adaptation, proactive adaptation. So again, proactive adaptation is obviously preferred, and we can say this with high confidence for warming ranges below 2 degrees C. Sometimes the model scenarios or these evaluations are not considered for higher temperature ranges, whereas here they are, but you can see that the confidence drops here as well. Similarly for malaria and dengue and other diseases carried by Aedes aegypti mosquitoes. Okay, there is a value to looking at regional impacts as well. So if you look at Africa and the Mediterranean, often associated with each other, Middle East and North Africa. Food production from crops, biodiversity and ecosystems in Africa, including fisheries and livestock in Africa here. Mortality and morbidity of heat and infectious disease in Africa. Delayed impacts of sea level rise in the Mediterranean. So sea level rise is going to be an issue for everybody, and you can see that this risk gets high very quickly beyond 1.5 to 2 degrees centigrade, whereas these still have some room till about 2 degrees centigrade, and confidence here is fairly high. Okay, what happens in the Mediterranean? Looking at water quality and availability, health and well-being, water scarcity in people in southeastern Europe, coastal flooding to people and infrastructure in Europe, heat stress, mortality and morbidity to people in Europe. As I'm recording this in 2022, UK and mainland Europe, continental Europe, have had record-breaking heat waves with large mortalities. Mortalities have been reduced since the 2003 event, I think, but you should check the numbers. But the frequency, duration and intensity of heat waves is argued to be increasing, potentially related to the Arctic warming, the polar amplification that we talked about, and sea ice loss. So you can see the risk levels tend to go up quickly once you cross 2 degrees C warming. In Australia, again, looking at loss and degradation of coral reefs, cascading impacts on cities and settlements, reduced viability of tourism related activities in North America, costs and damages related to maintenance and reconstruction of transportation infrastructure in North America, Lyme disease in North America under incomplete adaptation scenarios. So I'm not going to explain these for each of those, but you can see the range of risks that are considered for regional scales from Australia to North America. Lyme disease has already become very common in North America because of vegetation changes, warming and interactions between deers, humans and deer ticks carrying the Lyme disease. Looking at the Arctic and Antarctic, sea ice ecosystems from sea ice change in the Arctic. Already we are butting up against the risk. Serious losses already occurred. Changes in fisheries catch for pollock and Pacific cod in the Atlantic has still some room here, but very quickly gets to high risk if we hit beyond 3 degrees centigrade. Costs and losses for key infrastructure in the Arctic. Sea ice and sea ice dependent ecosystems in the Arctic. Changes in krill fisheries in the Antarctic. Krill is a rich, nutritious food for whales, which travel all the way from northern hemisphere across the equator into the Southern Ocean to feed the young cows because of this high nutrition and the timely bloom. So that is already being seriously affected. We are in this range. We can say with high confidence that we are already at a reasonable risk in terms of krill fisheries in the Antarctic, and they're going to get worse very quickly, and we can say that with some level of confidence as well. Okay, so again, I'm not going into deep details, but the future warming is already here. So the future is here, the impacts are already here, and yet we are emitting as usual. So we need to worry about where we are headed and what it would mean for the human societies. Of course, we are not talking so much about evolution anymore, but just talking about displacements of humans, which relates back to out of Africa and other scenarios we have talked about. We're talking about winners and losers and conflicts, which we have talked about in the context of Neanderthals and sapiens, and how Neanderthals may have gone extinct because of these things, and so on. So all these are still very relevant. So we'll come back and discuss a few more points along these lines. Okay.